Determine whether the following functions are concave up or concave down. And we've got three functions here, a, b, and c. Well, you might recall that concave up, what we know about concave up quadratic functions at the moment, each of these is a quadratic function. Concave up quadratic functions tend to take this form. They look like this. They look like a proper U or an opening, an upward opening function. Concave down, they have a graph that resembles this downward opening shape. And so this is sort of like an upside down U. And they both have arrows. They have arrows at the top and at the bottom here to indicate that this function goes upward forever and downward forever. So without the graph, you might think it may be hard to figure out whether a function is concave up or concave down, but actually it's quite simple. You might recall that we defined a quadratic function as a function that takes on this form, takes on the form f of x equals ax squared plus b x plus c, where a, b, and c are constants and a is not equal to 0. So this is a quadratic function. We could easily write y equals this statement on the right here as well. That would be the same. Those would both represent quadratic functions. So here, all we have to do to figure out whether a function is concave up or concave down is consider the sign of this a coefficient. And the rule is that if a is greater than 0, if a is greater than 0, then the quadratic function is concave up. Alternatively, if a is less than 0, then the quadratic function is concave down. Very simple. So that's interesting that this algebraic property, whether it's greater than 0 or less than 0, determines completely this graphic quality of the function. And note here that we never have a is equal to 0. We can never have that if it's a quadratic function. Thus, a will always be greater than 0 or less than 0. Okay, let's get straight to it. So here we have y equals x squared plus 4x plus 4. Well, let's examine the coefficient on this x squared variable. That's the a here. So here, a equals 1. We could easily write 1 times x squared here, and it would be exactly the same thing. So the coefficient on x squared is 1, and considering that 1 is greater than 0, we can say that this quadratic function, when graphed, will look like this. In other words, will look like this upward opening graph. So this is going to be concave up. Concave up. Very simple. What about the second one? Well, here we have y equals negative x squared plus 6x. This 6 looks like a bit of a b, but it's actually a 6. So negative x squared, well, that's the same as saying negative 1 times x squared. In other words, a here equals negative 1. So negative 1 is less than 0. Consequently, according to our rule, this function is going to be concave down. So this quadratic function is concave down. Okay, let's consider c. Y equals x plus 1 multiplied by 3 minus x. Now you might initially be skeptical as to whether this is a quadratic function or not. So in order to test whether it takes on this form, what we need to do is expand it. At the moment it's factored. So let's expand it. We'll say x times 3, that's 3x. Then x times negative x, well that's negative x squared, so negative x squared. Then we have plus 1 multiplied by 3, so that's going to be 3 times 1 is 3. Then we've got plus 1 times negative x, so it's going to be negative x. Okay, let's collect our like terms, and let's also arrange them from x squared, then x, then the constant. So here we're going to have negative x squared out the front. And then we've got plus 3x minus x. These are our common terms with x in them. So plus 3x minus x, that's going to equal 2x, so plus 2x. And then our constant term is going to be plus 3. So does this expression take on a form defined above here as a quadratic function? Well, yes it does. We have here minus 1 is a, 2 is b, and 3 is c. And sure enough, a does not equal 0. Well, we've got a minus minus x squared out the front here. This is the same as saying minus 1x squared. In other words, we have a equals minus 1. Well, here, minus 1 is less than 0. So since it's less than 0, this quadratic function is concave down. So in order to discover or uncover whether a particular quadratic function is concave up or concave down, all you have to do is look at the sign on the coefficient of x squared.